Open your book to page 446. This lesson is on the laws of logarithm. So there are three basic laws. So the first law is when you have log base b of m times n, this will equal to the log m plus the log n of base b. Okay. Now this is similar to, again, remember they are inverse function, right? So notice the multiplication, it becomes addition, right? So just like when you have, imagine that if you have like a b to the m times b to the n, okay? This will equal to what? This will become b to the m plus n, right? So you can see that. So that's where it came from. Again, they are inverse function of each other. So when you have multiplication, you add the exponents. Okay? So when you have multiplication, it becomes adding of the logs. Okay, so that's where it came from, right? Again, inverse function. Now the same thing, number 2, when you have log base b of m divided by n, this would be equal to log m base b minus log n base b. Right? Again, this is same thing as this. When you have b to the m divided by b to the n, when you have division, you subtract the exponents, so it becomes b to the m minus n, right? So this is the exponential function, this is the log function. You can see the similarity between the two. Okay? So again, when you have division, it becomes subtraction. When you have multiplication, it becomes addition because of this, right? Okay? So you can see the comparison. Now you go to 3. When you have log base b of m to the k, this will equal to k times log of m. This is same thing like if you have the b to the m to the k, this is equal to b to the m kind of times k, right? So it's kind of the same concept, but because m is your log, so you have to kind of put a k in the front. Okay, multiplication. So that's kind of the similarity between the two. Okay, so these are 3 laws that you need to memorize, to understand. So with that, let's go and look at some of the examples. So example 1, you have log base 5 of m to the 3 n squared, and you want to go and break these things down into the log m and log n. So first, what you do is go and separate the two. Okay, so this will equal to log m to the 3 plus log n to the 2 base 5, right? So separate the two, again, using the first law. When you have multiplication, it becomes the addition of the logs. Then after that, so what you do is go in orders. Apply 1, just go to the checklist, 1, 2, 3. So then you go to use the third law. So the 3 comes to the front, and the 2 comes to the front, and that's it for example 1. Now let's go to example 2. Example 2, you have log base 2 of square root of m over n to the 7. And again, you want to go and express this in terms of a log, right? So this is the division. You know, that right now it's kind of probably a bit confusing. So I'm going to go and write this in the exponential form. Get rid of the square root first. So this is m to the 1/2 power, and this is n to the 7/2 power. Right? Get rid of the square root first. Square root means half power, right? Okay, then after that, this is division, so I'm going to use the second law. So this would be equal to log of m to the 1/2 power minus log of n to the 7/2 power with the base 2. Then after that, apply the third law to bring the exponent down to the front. Okay, and that's it for example 2. So just apply the first law or second law, then you apply the third law. Okay, let's go to example 3. So this is something new, so if we take a little while to get used to, but after you practice and get used to it, it's not that bad. Okay, so that is to break it down. So now you're going to do the opposite direction. You're going to put them together. Okay, so example 3, you have log base 10 of p plus 3 log base 10 of q, and you're going to write it together as a single log. So in order to have a single log, you cannot have a number in front like that. So you have to go backwards. You have to put this up to the top first. So you need to bring this 3 to the top. Okay, so this goes up here. Okay, this is the reverse of the log, the number 3. So now you have a log of something with the same base. Now you can bring them together. So this becomes log of pq to the 3 power. Okay, so pq 3 power, and that's it. Okay, so it's going to reverse. Okay, now let's go to example 4. So you're giving that the log of 2 is equal to 0.30 and log of 3 equal to 0.48. Now there are 2 logs that is not giving, but you need to know. That is the log of 10 base 10, this is equal to 1, and log of 1 equal to 0. Okay, so those 2 you need to know. We covered this earlier, right? When they are the same, it's equal to 1, and when the log of 1 equal to 0. Okay, so these 2 you need to know. Okay, so now you're going to use this information to go and evaluate. So for A, you're going to evaluate log of 18. So you need to figure out what does that equal to. So what you need to do is you need to break down the 18 into those numbers. Okay. So 18 is equal to 2 times 3 times 3, right? 18 is equal to 2 times 3 times 3. And the reason I use 2 and 3 because that's what it's given, so you know those numbers. So you have to use those numbers. Okay, and then so this is equal to, now multiplication becomes what? This becomes log of 2 plus log of 3 plus log of 3, right? Multiplication becomes additional logs from the first law. So now we can evaluate. So log of 2 is equal to 0.30, log of 3 is 0.48 and 0.48, and you add them together, okay, you're going to get 1.26. Okay, so that's what you do with A. Okay, now let's go and do B. Example 4b. Okay, you have log of 20 over 3. So again, you've got to use this information, right? So this is going to be equal to log of 2 times 10 over 3. Right? 20 is 2 times 10, and those are the one you can use, right? See over here, right? Because it's base 10. So this becomes log of 2 plus log of 10 minus log of 3. Right? When you multiplication, you add, divide, you subtract. And now you can evaluate. So log of 2 is 0.30. Log of 10 is 1. Right, from here, right? That cancels out, right? Okay, and log of 3 is 0.48. And so when you add all this together, you get 0.82. Okay, let's go to example 4c. Okay, you have log of 5 base 10 So again, you only can use those numbers, so you have to do these. So 5 is equal to 10 over 2. Right? You only can use 2, 3, and 10. And so this will equal to log 10 minus log of 2. And so this is equal to 1 minus 0.30. So this is equal to 0.70. By the way, the logs is to use to deal with numbers that are extremely large or extremely small. Okay, for example, like when you deal with chemistry, right, you deal with electrons, the numbers are very small. Or you deal with astronomy, the numbers are extremely big. And so calculation will be a little bit complicated. And so you can use log. And it's extremely useful in the old days because they don't have calculator. And that's how they can, able to do calculations. Okay, let's go to example 4D. You have log base 10 of 1 over cube root of 8, cube root of 2. Okay, so let's go ahead and get rid of the radicals. So this becomes 2 to the negative 1/3 power. Right? So this 1/2, 2 to the negative 1/3 power. Okay, and then you can apply the third law. So this is equal to negative 1/3 log of 2 base 10. Now you can evaluate. So this is negative 1/3 times 0.30. So it's going to be equal to negative 0.1. And that's it. Okay. So again, whenever you have radicals, get rid of it. Make it into exponential form, and then you can go from there. Okay, let's go to example 5. So you have to solve equations now. You have log x of base 6 plus log of x minus 5 base 6 is equal to 2. So what you want to do is, whenever you have log equation, you want to get into a single log. Okay, so now you got 2 logs, right? So you need to go and get this together. Now it's addition of the logs, means you have to multiply the inside, right, using the first law. So it becomes log of x squared minus 5x base 6 is equal to 2. Right? Again, when you're adding the logs, think of like exponent. You have to, this is the first law, right? The reverse of the first law. See, when you have adding, you multiply the inside. Okay? So that's what I did. I multiply the inside. That's why I get this from. So now you can, once you get a single log, so you can use a change of forms. So you're going to get 6 squared is equal to x squared minus 5x. Right? 6 squared equal to x squared minus 5x. And then you have to make it equal to 0 to do the factoring. So minus 36 on both sides. So you got 0 equal to x squared minus 5x minus 36. Then you have to do the factoring. So use your master product. So again, if you don't know the number, you just have 1 comma negative 36, 2 comma negative 18, 3 comma negative 12, okay, 4 comma negative 9, and that's it, right? Okay, so you're going to get plus 4 and minus 9. So you're going to get x equal to negative 4 and x equal to 9. Okay, now you have to be careful. Whenever you're dealing with logs, right? You have to put your numbers back in original equation and check. You cannot have a log of a negative number. Okay? So you can have a log of a negative number. So if you put this over here, it's no good. So this one is no good. Now you put this one over here, it's good. You put this one over here, 9 minus 5 is 4, so you're still good. So only one answer is good. So again, you cannot have a log of a negative number. And so that's it. Okay, so let's go and do some practice.